Hello people, welcome to Science Jump. Today we're going to be talking about land breeze and sea breeze. In order to understand this, you have to understand specific heat capacity. Water's got a very high specific heat capacity. This means that it takes a long time to warm up, but once it's warm, it stays warm for a very long time. This means that during the day, the water is going to be colder than the land. And during the nighttime, what happens is the land releases all of its heat, whereas the sea holds onto its heat. So now at nighttime, it's hot over here and cold over there. The other part that you need to know is about convection currents. With convection currents, basically, you got an area of warm air, and as it gets warm, it becomes less dense because the particles spread out. And then as it cools down, it becomes more dense. So with convection currents, what happens is air particles, when they're given lots and lots of heat, they end up spreading out like so. That causes them to become less dense and they rise. And it's replaced by colder air, otherwise it's going to leave a vacuum. So you end up with this circulating thing of air, movement of air, where the warm air rises because it's less dense, and it's replaced by colder air, and the whole thing just keeps on moving and moving round and round in circles. And this is what's happening over here with the sea breeze. So the first one is a sea breeze. Remember, a breeze is a refreshing cold gust of air. So during the sea breeze, what's happening is the warm air is less dense and it rises, and it's replaced by cold air from the sea. At nighttime, the exact opposite happens. The warm air is now over the water because the heat has been kept in by the water, and it rises because it's less dense. And then the cooler, more dense air comes in from the land, and it causes a refreshing breeze if you're out at sea. And that's basically all it is. Thank you very much for watching, and goodbye.